All right, hey everybody. My name is Matthew Zipkin. I work for a company called Impervious.com, and we focus on Handshake and Bitcoin development. In the next 20 minutes, I'm going to be introducing Handshake to you. I assume maybe you've heard of it, but maybe don't have so many details. So I can get this, and that's good. All right, if someone can just drop in the chat that everything looks good and you can see my slides, that'd be great. So we'll just get right into it. I have a tendency to rant when I am really excited about something, so I'm going to try to keep it brief because I know I only have about 20 minutes. So what is Handshake? Handshake is an experimental peer-to-peer root naming system. It is an alternative DNS root zone secured by proof of work, and with that it can provide decentralized certificate authority. So everybody knows, hopefully, that DNS is how computers find each other on the internet, using human readable names. Technically, we achieve this goal with a cryptocurrency called HNS. That's the ticker symbol, and it is an independent blockchain. This is a frequently asked question. It is not an Ethereum contract. It is not a layer 2. It is not a side chain. It is a brand new blockchain. You can think of it as a smart contract platform with one smart contract, and that's DNS. It's based on Bitcoin. It's actually a fork of Bitcoin written by JJ, who was just introduced. So it has a Bitcoin-like ledger of coin ownership. HNS and BTC work almost exactly the same way. But Handshake has a second ledger that contains and manages the root zone DNS data, the names and the data that goes with it. And then technically it is a protocol. And I add this because some people don't understand how blockchain works. I think this crowd is probably an exception. So let's talk about DNS really quick. Let's talk about the root zone. Handshake does not decentralize DNS. It does not decentralize the internet. These two things are already decentralized by design. And that's why they work so well, frankly, both DNS and the internet. The thing about DNS that is not decentralized is this little guy right here up on the top, the root zone. DNS works like a tree-based authority structure. There is one god of authority up here on the top. It's called ICANN. It's a nonprofit organization based out of Los Angeles, I think, in California. And they delegate authority to these top-level domains that you're familiar with, .com, .org, .net. And then each of those domains can delegate further authority, google.com, facebook.com, bitcoin.com. And then each of those little organizations can do even further delegation, www.google.com, stuff like that.
Matthew,
sorry.
We lost your slides. Can you restart it, please?
Oh, okay. Boy, that sucks. Let me see. Chrome tab. Here we go.
Perfect.
I need audio from Chrome. Okay, great. Thank you for bothering me. Great. Next slide. So the Handshake root zone works like this. So we're going to replace that central authority figure on the top. We're going to replace the root zone managed by ICANN, replace that by a proof of work blockchain. And this means that we can add any top level domains that we want. And we have our blockchain protocol where you can do auctions on chain. I'll explain in a minute. And this is where the top level domains in the Handshake root zone come from. So as opposed to .com, .org, .info, in Handshake, we have these additional top level domains. There's 2 million of them so far on chain right now, after only about a year and a half of mainnet activity. Here's a couple fun examples: Galaxy, Venue, Castle, ICANN, Orchid. These are all top-level domains. So .galaxy, .venue, .castle work just like .com, .org, .info. These are examples of actual resolvable Handshake URLs, HTTPS library genesis, just like that. No second-level domain, no dot. These URLs look very sexy, very appealing. No .com. You are not beholden to .com VeriSign's authority. You're not beholden to .org. Nobody can take these names away from you. You own them with a private key. They're secured by proof of work. It's badass, and they look totally awesome. Handshake.txt. If you had a Handshake Resolver, you could find the design notes, our white paper there. And then inside of the Handshake Resolver, we combine these two root zones. So these are images from the last two slides I showed you. We've got the ICANN root zone with its authoritative structure on the left, and on the right, we have the blockchain, Handshake blockchain with the top-level domains that emerge from it there. And the Handshake root authoritative name server combines them both. So I've been using Handshake software on every single one of my devices for over 2 years. I've never had a problem going to any .com, .org, .net site. In addition, I can also go to sites hosted on Galaxy, Venue, Castle. I can police outside my window. Hopefully they're not coming for me. That would be a very short talk. Okay, so all the top level domains are merged. And in this way, Handshake extends the ICANN root zone, does not replace it. There are some collisions that are possible. We could talk about that later. But for now, like as an introduction, Handshake extends the DNS system, does not replace it. You can use them both. Next thing we're going to talk about is certificate authority. So this is how you get that S in the HTTPS. This is the thing that makes web browsing secure. This is how you can trust the Bitcoin address you see on the website. This is how you can enter your bank account password without losing all your money. This is how you can organize a democratic revolt without thinking that the data on the website organizing everybody has been manipulated somehow. You need to know that your browser is talking to that server that you expect to be talking to, and that nobody is messing with that data. Unfortunately, the way that this works is with something called certificate authority, which is, us being in decentralized blockchain land seems kind of like a silly thing. But so here's my example. If you go to bitcoin.com in a regular browser and you look at you click the lock and get the certificate notes, you'll see this, that bitcoin.com has been issued a certificate by Cloudflare, which it in itself has been issued a certificate by something called Baltimore Cyber Trust Root. Has anybody ever heard of Baltimore Cyber Trust Root before? Probably not. But it is installed on your computer. On the right, I've just taken a screenshot of a short section of the certificate authority certificates that are just installed on your computer. You just trust them. Why? Because you bought a computer and you walked out of the store with it. Those certificates were just there. The person you bought the computer from put them there. The person who designed your operating system put them there. And you can manipulate them, but the point is that we have this trust pyramid again, where there is these authorities on top that just come with your operating system, like Baltimore Cyber Trust, and they are effectively responsible for securing your connection to Bitcoin.com. Okay, so these two pyramids of authority is what Handshake seeks to replace or improve or extend, I'll say. And I'm going to introduce a technology called DANE. This stands for Domain Authentication of Named Entities, something like that. This is not a new technology. It was not invented by the Handshake developers. It's actually been around for a long time. I want to say like 10 or 15 years or something like that. And it's never caught on with browsers, and there's a bunch of reasons for that. But what this does is it ties together certificate, authority, and DNS into basically one system. So instead of relying on certificate authorities, their certificates basically come from the DNS. I'll explain this very briefly. Basically, when you have a web server like this handsome robot on the left here, you have an SSL certificate, which is a public key that you use to encrypt your communication. Normally, that key has to be signed by, for example, Baltimore Cyber Trust Root. That's why you trust it. In our model, what we do instead is we take a hash of that certificate and we put it in the DNS system. Now, in legacy DNS, that doesn't make any sense because you're just trading one government authoritative system for another, and it's slower and doesn't really make a whole lot of sense. And that's why DANE has sort of failed to gain adoption, even though it's been repeatedly proposed by like the IETF and lots of very smart people. But blockchain naming gives DANE new life. And not just Handshake, but everything, ENS, YAT, Butterfly Protocol, .btc on stacks, Namecoin, there's a ton of these. And certificate authorities don't authorize certificates on any of these naming systems. So we got to do something. And what we have is a very secure domain naming system. It's secured by proof of work and your own private key. So what you do is, in short, you take your SSL certificate and you add it to your DNS, the same way that you would add the IP address of your web server. Now you also add the hash of your certificate. And the client, your laptop, when you browse to https://library Genesis, this process happens. You get the SSL certificate, and instead of looking to see who signed it, maybe it was Baltimore Cyber Trust Root, they're not going to sign that certificate. Instead, you're going to find that that certificate is hashed and is added to the DNS system, which you know is secure because your computer is verifying proof of work. Very, very exciting. Just like gets me fired up. And so here's a beautiful example of how we're doing this conveniently now on Handshake. The company I work for, Impervious, has released a menu bar application called Fingertip a few months ago, designed by my colleague Buffer, who is just brilliant and is really just a gift to the ecosystem for this kind of work. What Fingertip does is it combines two very important pieces of software into one. One is a light client written in C called HNSD that verifies the proof of work of the Handshake blockchain and can get root zone name data from the network without going through any central API or anything like that. It gets the DNS lookup answers directly from the peer-to-peer network. The second thing it has is something that Buffer wrote personally called Let's Dane, and it is a friendly man-in-the-middle proxy that verifies Dane. So it handles the certificate stuff. So we've got the two pieces of software wrapped into Fingertip. You install it, and you can connect it to any browser you want. You don't need to wait for Chrome to adopt Handshake. You don't need to wait for Brave to adopt Handshake. And while we're on the subject, if you happen to look at the code on how Brave adopted ENS, the code is very, very simple. There's a file in the Brave code base called decentralized DNS. And if you look at it, it just goes to cloudflare.com and asks them for the website. So it's like, what are we doing here, everybody? We got a blockchain. Are we decentralizing stuff? Are we trusting people? Are we not? With Fingertip, you're not trusting anybody. You're getting that DNS information directly from the blockchain. You don't need to trust it. You verify it. And then you get that the HTTPS, you get the security directly from the web server. Everything's verified, and you can go to a beautiful website like hns.blockclock, which is a website that I run that's kind of a artistic block explorer. So there we go. You can get security. It's easy. There's public resolvers for Handshake stuff too. Don't use them. Install Fingertip. This is the way. And this light client is a really important part of the design from Handshake, which was built for this reason. The reason we have a brand new blockchain instead of building on Ethereum is for this use case. It's so that individuals can install a very small, lightweight piece of software in their computer and securely browse Handshake domains without trusting Cloudflare or Brave or Infura. It's all right there. Okay, so Handshake can scale, and I mentioned a few other blockchain-based naming systems. None of them have a light client, as far as I know. Most of them could, with soft forks or hard forks, maybe get there. I don't know if anybody runs an Ethereum light client or if such a thing is even possible. The picture on the right here is a Raspberry Pi. This is a $5 computer. It is cheap. This kind of hardware can be deployed to the edges of the internet, to the periphery of the technology community. I'm talking about villages in countries where bandwidth is low, technology is rare. I mean, like, how many billions of people are there on the earth, and how many of them have got a laptop with a great connection to Infura? We've got to think about everybody. So the Handshake light client can run on this computer because it's so lightweight, and it just verifies these proofs, and it can connect directly to the Handshake blockchain without going through a central authority. There's some other interesting data on this slide. The Handshake blockchain is limited to about 63 or 64 million top-level domains. That's not a very explicit limit. It depends on how many renewals are allowed per block. I think this capacity is important. What it means is that there is not one Handshake domain for every person on Earth. We're not going to make that promise. It just won't scale. The capacity is important, and that's what's going to allow it to scale, so that people can use this cheap equipment to access the network freely. And finally, our blockchain is referral only. This is a bit of a subtlety when it comes to DNS, but basically, you cannot put the IP address for your website on chain. You can't put you can put some text records, so there's some variety you could add if you really wanted to put a Bitcoin address, for example, right on your domain name. But the way that DNS scales by design, not just Handshake, but DNS in general, is by referring to other machines. So the blockchain should just be used for an IP address and a public key. In DNS, we call this an NS and a DS record. And then you go talk to that computer at that IP address, verify the data you get back because you know it's public key. And then all the hard stuff, the Bitcoin address, the Ethereum address, whatever you want to do with the big blobs of data, don't put that on the blockchain. Put it over there and refer to it using a public key and an IP address. That's how we can scale. And I added a summary to the bottom of the slide too. Decentralization must apply to the users as well, not just the application. So Ethereum name system is awesome. It's decentralized. It's on Ethereum. It's censorship resistant. But how are users accessing ENS? How do I go to orchid.eth? What's going to happen there? The truth is, if you wanted to do it censorship resistantly, privately, securely, you would need your own Ethereum full node and also an IPFS full node. Does that scale? I don't think so. Handshake was designed to scale for the users, not just for the application, but for the people who want to access it. You don't need a wallet. You don't need to trade HNS for BTC. You don't need to know anything about cryptocurrency or store a private key to view a Handshake website. What else have we got? Privacy. Okay, this is a privacy conference. Unfortunately, Handshake is based on Bitcoin, and so there's a lot of privacy trade-offs because, like Bitcoin, Handshake is pseudonymous. And so, there's addresses that can be linked with investigative techniques. But there is some privacy aspects that are worth mentioning since this is a privacy conference. First of all, there's no whois database. When you get, zoom.us or orchid.io, whatever, twitter.com, there's a registry, and ICANN, the authoritative boss, requires some kind of personal data about who owns what website. Forget that. We're a blockchain. Everything's private public key. Also, Handshake has a massive, massive airdrop that went out to over 180,000 developers, popular developers, open source developers on GitHub. And they can redeem their HNS airdrop using the PGP public key that's in their GitHub account. So it's kind of an interesting onboarding mechanism that doesn't require them going through an exchange and buying stuff with dollars. In the first year of Handshake's life, this program is now over based on consensus rules, but there's also a really interesting cryptographic blinding technique added for RSA keys to make them even more private. Click the link to learn more. The P2P network itself also has an encrypted layer. I think JJ mentioned the alligator squared property. The connection is obfuscated, and after that, the connection is encrypted. Also, the idea behind Handshake, like I mentioned with Fingertip, or if you run a HSD full node, is that the DNS is resolved locally on your computer. And whether or not you're using Handshake or not, this is already a huge boost for privacy. Because when you type, Pornhub.com on your computer, that string is going right to Verizon. It's going to Comcast. It's going to your internet service provider. They know every name you type into your browser. Probably whoever makes your browser does too. Having a local DNS resolver, whether or not you're using Handshake, is already taking that power back. Your ISP can still try to stiff your connection and try to guess what website you're going to based on the IP, but having the DNS recursion locally is a boost. And then finally, the Lite client has some trade-offs. All right, I see I've got 3 minutes left, so I'm kind of just going to breeze through the rest of this stuff. I hope you guys are as excited about Handshake as I am. This is kind of interesting. The way the names are dispersed on chain is through an auction system. People bid on names, and then the bids are blinded, and then you reveal the bid after a few days. Then you can register the name and use an update command to add DNS data. You can claim a certain amount of names, something like 80,000 names have been reserved from the current ICANN domain space, stuff like Facebook and Google. You can't just open an auction for those names on Handshake for the first couple of years, but they can be claimed using a DNSSEC proof. And of course, names can be transferred. I'll just breeze really quick. I got 2 minutes left. I'm going to show you some screenshots of some UIs. Namebase is a very popular website where you can bid on auctions. Bob Wallet is a desktop full node application where you can bid on Handshake auctions. This is how DNS management looks on Namebase, and again on Bob Wallet. Very simply, just add DNS records. If you've ever used GoDaddy or Namecheap, you're familiar with this kind of interface. And finally, the community is decentralized. There is no central authority. There is no foundation. There is no funding. There's no marketing budget. There's no president, no CEO or CTO or anything like that. We're kind of all over the place. People start Telegram rooms and Discord servers and IRC channels, and it can be a little daunting to sort of figure out where you're supposed to be. But the point is, you just find a channel that works for you and ask questions. And the most excited players are everywhere. I have 1 million chat apps open every day, so I'm able to find questions from everybody. And finally, the Twitter is also a really great frequently asked question. The @HNS handle was started by the project founders a long time ago, and as a great symbol of how our community is decentralized, it's no longer in use. What we want you to do is to find individuals tweeting about Handshake using the hashtag, and to not trust or rely on that central authority at HNS or any central authority, because that's what this whole project is about. Thank you so much for your time, and reach out if you have any questions about Handshake. Thank you.
Thanks a lot, Matthew. That was a great introduction. I didn't know that there was this little toolbar app for Mac OS, Windows, Linux. I've got it now. It's syncing.
Awesome.
I actually
It'll only
bought.
take
Sorry, how long is it going to take?
just a minute to sync. Yeah.
Okay, terrific. Yeah, I've got a lot going on my laptop here, so it might take a little bit longer. I got 3 streams. I've got this going. I've got a lot going on, but that's terrific. I think one quick thing to highlight is just how seizure resistant these are, and I wanted to actually talk about that in a little bit. But yeah, just thank you very much for that. I guess if people have funding that they like to throw at this, is there a way to do that? Maybe through Impervious's website or Handshake's website?
Sure. The Discord I have here, I mean, any of those are fine. I can hook you up with people. There are a couple funding projects. One is called Handshake Institute. Another is HNS Fund. Another is DWeb Foundation, which I believe is a sponsor of today's conference. All those mechanisms channel money to workers.
Okay, that's good to hear. Yeah, no, that's terrific. So thank you very much again. And we're going to move on to the next segment here. So we've been through free internet, free money, free thought. We've started freedom by design. Privacy by design remains the North Star of cryptographic and privacy-first commercial work. The economics of privacy by design requires customer choice to be engaged, of course. That's why we need strong incentives, attractive tooling. We've been talking about that, and obviously suitable use cases. We've also heard a little bit about that. So we're looking beyond Taproot, and congrats to the Bitcoin community once again on enabling that today.